My topic is exception handling in Java. Let's see a content. Introduction. What is exception handling? What is error? Difference between errors and exception. Types of exception. How those JVM handle an exception. How programmer handle an exception. Exception handling with method overriding in Java. Last conclusion. Exception handling. Exception handling in Java is one of the effective means to handle runtime errors so that the regular flow of the application can be preserved. Java exception handling is a mechanism to handle runtime errors such as class not found exception, input-output exception, SQL exception, remote exception, etc. Let us see about exception in Java. What are the Java exceptions? In Java, exception is an unwanted, either unexpected event which occurs during the execution of a program. Let us see an example at a runtime that disrupts the normal flow of the programmer's instructions. Exception can be caught and handled by the program. When an exception occurs within a method, it creates an object. This object is called exception object. It contains information of the exception and the state of the program when the exception occurs. The next major reasons why an exception occurs. The first, invalid user input, device failure, loss of network connection, physical limitation that is out of disk memory. The next, code errors, out of bound, null reference, type mismatch, opening unavailable files, database errors, the final arithmetic errors. The next, error. Error represents irrecoverable conditions such as Java virtual machine running out of memory, memory leaks, stack overflow errors, library incountability, infinite recursions, etc. Errors are usually beyond the control of the programmers and we should not try to handle errors. The next difference between errors and exception. Let us discuss about the most important part, which is the difference between errors and exception. Let us follow. The first, error. An error indicates a serious problem that a reasonable application should not try to catch. Exception indicates condition that a reasonable application might try to catch. Error is an illegal operation performed by the user which results in the abnormal working of the program. Programming errors often remain undetected until the program is compiled or executed. Some of the errors inhibit the programs from getting compiled or executed, thus the error should be removed before compiling and executing. The most common errors can be broadly classified as follows. The first, runtime error. Runtime errors occurs either we can say or detected during the execution of the program. Sometimes these are discovered when the users enter invalid data, either data which is not relevant. Runtime errors occurs when a program does not contain any syntax errors, but asks the computer to do something that the computer is unable to reliably do. During compilation, the compiler has no technique to detect these kinds of errors. It is the JVM, Java Virtual Machine, handle the error during the runtime. We can put our error code inside the try block and catch error inside the catch block. The next type, compile time error. Compile time errors are those errors which prevent the code from the running because of an incorrect syntax such as missing semicolons at the end of the statements, either missing brackets, class not found, etc. These errors are detected by the Java compilers and the error messages is displayed on the screen while compiling. Compile time errors are sometimes also referred as syntax errors. This kind of errors are easy to spot and rectify because the Java compiler finds them for you. The compiler will tell you which pieces of code in the program got in trouble and its best guess as to what you did wrong. Usually, the compiler indicates the exact line where the error is either. Sometimes the line just before it. Braces, the actual error may be at the beginning of the line. In effect, syntax error represents the grammatical errors in the use of the program languages. The next type, logical error. A logic error is when your program compiles and executes but does the wrong thing, either returns an incorrect result or no output, and it should be returning an output. These errors are detected neither by the compiler nor by the JVM, that is a Java Virtual Machine. The Java system has no idea what your program is supposed to do, so it provides no additional information to help you to find the error. These errors are caused due to incorrect idea or concept used by programmers while coding. Syntax errors are grammatical errors, that is, whereas logical errors are errors arising out of incorrect meaning. For example, if a programmer accidentally added two variables when here seen need to be divided, then the program will give error and will execute successfully but with an incorrect result. The next, exception hierarchy. All exceptions and error types are subclasses of the class, that is throwable, which is the base class of the hierarchy. One branch is headed by exception. This program should catch null pointer exception. Is an example of such an exception. Another branch is error. Is used by the Java runtime key system, that is a JVM, to indicate errors having to do with the time of runtime environment itself, that is a JRE. As stack overflow error is an example of such an error. The next types of exception. Java defines several types of exception that relate to its various class library. Java also allows user to define their own exception. Exception can be categorized into two ways. That is a built-in exception. The next, user-defined exception. The first, built-in exception, that is a checked exception and unchecked exception. Built-in exceptions are the exceptions that are available in the Java library. These exceptions are suitable to explain certain error situations. The first, checked exception. Checked exceptions are called the compile time exception because these exceptions are checked at compile time by the compiler. The next, unchecked exception. The unchecked exceptions are just opposite to the checked exception. That is, the compiler will not check these exceptions at compile time. It is simple that if your program throws an unchecked exception and even if we do not handle or declare it, the program would not give a completion error. The next, arithmetic exception. It is true when an exception condition has occurred in an arithmetic operation. The second, array index outbounds exception. It is a true and indicate that an error has been associated with an illegal indexes. The indexes is either negative or greater than or equal to the size of the array. The next, class not found exception. This exception is arised when we try to access a class whose definition is not found. The next, file not found exception. This exception is arised when your file is not accessible or does not open. The next, input-output exception. It is true when an input-output operation failed or interrupted. The next, interrupted exception. It is true when your thread is waiting, sleeping, either doing some processing and it's interrupted. The next, no such field exception. Is true when a class does not contain the field, that is either variable specified. The next, no such method exception. It's true when accessing a method that is not found. The next, null pointer exception. This exception is arised only when we are referring the numbers of null object. Null represents nothing. The next, number format exception. This exception is arised when a method does not convert string into numeric format, that is words for number anything. The next, runtime exception. This represents an exception that occurs during runtime only. The next, string index outbounds exception. It's thrown by string class method to indicate that an index is an either negative, either greater than the size of the string. The next, illegal argument exception. This exception is true the error or error statement when the methods receive an argument which is not accurately equal to the given radiation relations or conditions. It comes under the unchecked exception. The next, illegal state exception. This exception will not accessed for the particular operation in the application. It comes under the unchecked exception. Let's see here, user-defined exception. Sometimes the built-in exception in Java are not able to describe a certain situation. In such cases, user can also create exceptions which are called user-defined exception. Your user-defined exception with the following steps. That is, the user should create an exception class as the subclass of the exception class. Since all the exceptions are subclass of the exception class, the user should also make his class a subclass of it. The first, checked and unchecked exceptions in Java exception, unwanted or unexpected event. These are the exceptions that are checked at compile time. If some code within a method throws and handle exceptions, it must specify exception using throws keywords. Checked exception can be fully checked or partially checked. The next, fully checked exception. A checked exception wherever its child classes are also checked. For example, input-output exception, injected exception. The next type, partially checked exception. A checked exception where some of the child classes are unchecked. For example, exception. Checked exception represents invalid conditions in areas outside the immediate control of the program like memory, network, file system, etc. Any checked exception is a subclass of exceptions. Unlike checked exceptions, must be either called by the caller or list as a part of the method signatures using the throws keywords. The next, unchecked exceptions in Java. These are the exceptions that are not checked at the compile time. Let's see, and the throwable runtime exception classes are unchecked exception. Everything else under throwable is checked. Unchecked exceptions or runtime exceptions are not required to be caught or declared in through class. These exceptions are usually caused by programming errors such as attempting to index out of bounds in an array attempting to be divided by 0. Unchecked exceptions include all subclasses of the runtime exception class as well as error class and its subclass. The separation into checked and unchecked exception sounded like good idea at the time. However, over the years, it is introduced more bilateral and less aesthetically pleasing code patterns. Then it's solved real problems. The typical, unfortunately quite cumbersome pattern within your Java ecosystem is to hide or wrap the checked exception within an unchecked one. Some examples of unchecked exceptions in Java. The first, array index bound of exception. This exception is thrown when you attempt to access an array index that is out of bounds. The next, null pointer exception, we already seen expected. This exception is thrown when you attempt to access a null object reference. The next, arithmetic exception. This exception is thrown when you attempt to divide it by 0 or perform an invalid arithmetic operation. The advantages of exception handling in Java. Provision to complete program execution. The second is the identification of program code and error handling code. Propagations of errors, meaningful error reporting, identifying error types. The next, how does JVM handle an exception? The first, default exception handling. Whenever inside a method, if an exception has occurred, the method creates an object known as exception object and hands it off to the runtime system, that is a Java virtual machine. The exception objects contain the name and descriptions of the exception and the current state of the program where the exception has occurred. Creating the exception objects and handling it in the runtime system. It's called throwing an exception. There might be a list of methods that have been called to get the method where an exception occurred. This ordered list of methods is called call stack. Now the following procedures will happen. The runtime system searches the call stack to find the methods that contain a block of code that can handle the occurred exception. The black of code is called the exception handler. The runtime system starts searching from the method which is the exception occurred and proceeds through the call stack in the reverse order, which is the method called. It finds an appropriate handler that it passes the occurred exception to it. An appropriate handler means the type of exception object through matches the type of exception object it can handle. The next, if the runtime system searches all the methods on the call stack do not found the appropriate handler, then the runtime system hand over the exception object to the default exception handler. Finally, we are seeing about default exception handler. That is which is the part of the runtime system, that is a JVM, Java Virtual Machine. This handler prints the exception information in the following format and terminate the program abnormally. The next, how programmers handle an exception. Customize the exception handling in Java. Exception handling is managed via 5 keywords, that is a try, catch, true, truth, and finally. Here is how they work. A program statements that you think can hide the exception are contained within a try block. If an exception occurs within the try block, it is a tune your code and catch this exception using catch block and handle it some rational manner. System generated exceptions are automatically tuned by the Java runtime system. To manually tune an exception, that is tuned out of methods, must be specified such as by truth clauses. Any code that is absolutely must be executed after try block completes it and put in a finally black. The key points of needed, remember the blocks. The first, in a methods there can be more than one statement that might do an exception. So put all this statement within the own try block and provide a separate exception handler within the own catch block for each of them. The next, if an exception occur within the try block, that the exception is handled by the exception handler associated with it. To associate with the exception handler, we must put a catch block. After it, there can be more than one exception handler. Each catch block is an exception handler. It handles the exception to the type indicated by this argument. The argument exception type declares all the type of the exception that it can be handled and must be the name of the class that inherit from the tuple class. For each try block, there can be 0 or more catch blocks, but only one final block. That is, the final block is optional. It always gets executed whether an exception occurred in try block or not. If an exception occurs, then it will be executed after try and catch blocks. And if an exception does not occur, then it will be executed after try block. The finally block in Java is used to put important codes such as cleanup code. If we are write system access in the try block, then finally block will not be executed. The next, exception handling with method overriding in Java. An exception is an unwanted error, unexpected event which occurs during the execution of a program. For example, runtime that disrupts the normal flow of the program instruction. Exception handling is used to handle runtime errors. It helps maintain the normal flow of the program. If any object-oriented programming language, that is C or C++, overriding is the features that flows subclass ignore child class to provide a specific implementation of your method, that is a specified implementation of your method that is already provided by one of its superclass, ignore parent class. When a method is a subclass, has the same name, same parameters or signatures, and same return type, that is a subtype, as a method is a superclass. Then the method is the subclass is said to be override the method in the superclass. The next, exception handling with a method overriding. An exception handling involved with overriding, that is ambiguity accuracy. The compiler gets confused to which the definition is to be followed. Type of the problems, there are two types of problems associated with it, which are the follows. The first problem is if the superclass does not declare an exception. The second problem is if the superclass declare an exception. Let us discuss different causes under this problem and perceive the outputs. The first problem is if the superclass does not declare the exception. In this problem, two causes that will arise as follows. The first case is if superclasses does not declare any exception and subclass declare checked exception. The second case, if superclass does not declare any exception and subclass declare unchecked exception. Finally, we have seen our conclusion. So, an exception in Java must be either caught or declared in the method signature or present in conditions outside the program's control. And second, exception typically caused by the programming errors are not required to be caught or declared. Understanding the difference between this exception helps write more robust and error-free code. Thank you.